Okay. So write down that essential question if you didn't get it. How do you use separation of variables to find the solution to a differential equation? Again, this is review, but this is an important review because there's a AP question typically on this. So you want to be ready for this one. It comes up, I'd say more than it doesn't on the BC test, but every once in a while it's not there. So, all right, go ahead and fill in the blanks. So basically what we do with the separation of variables is we take and get all the x's with the dx, all the y's with the dy, and then we integrate both sides, okay? We call that procedure separation of variables. That shouldn't be news to us, okay? All right, so let's practice this a couple of times. Again, these should be very familiar to us. So I've got to get the dx to the other side and this to the other side. So how do we move this piece to the other side? Divide, right? Okay, so I'm going to keep the dy. I'm going to keep the x. I know I've got to divide by the x squared plus 4. How do we move the dx? Multiply. And then how do I move this y? Divide it. So it's going to look like that. Now we solve it, or we find the general solution by integrating both sides. All right, when we integrate 1 over y, what do we get? Natural log of y, okay? And that's all we're going to do on that side for a little while. Over here, we've got more work to do. Can I just do natural log on this side? What do we need to do? U substitution first. So what are you going to use as your u? Good. So du equals 2x dx. I'm going to, I keep the x, I got to move the 2, so 1/2 du equals x dx. Now let's use our u substitution in here. So what's going in for the x squared plus 4? U. Okay, what's going in for the x dx? Good. All right, when we integrate 1 over u, what do we end up with? Natural log, absolute value of, and we get this mess right here, right? The absolute value of that, is it ever going to be negative? Or would it in the inside ever be negative? Do I really need the absolute values then? No. It kind of takes care of itself. Plus, and this is where we put the c sub 1 thing in. Okay, let's talk about properties of logs for a minute. Remember when we have a number in front, we're allowed to take that and make it the what? The exponent. So this could really be to the 1/2 power. What's a fancier way of writing the 1/2 power? A square root. Good. So natural log of square root of x squared plus 4 plus c sub 1. All right. I did that because I want to try to get rid of the natural logs and get this in, because a general solution means I need something that looks like y equals. Okay? So how do we get rid of the natural log? E. So e to the natural log of y equals e to the natural log of the square root of x squared plus 4 plus c sub 1. Alright, this is where things get tricky. These guys cancel. So we've got y equals. You can't cancel this because of that plus sign right there. So remember, this is the thing where we have to tear it apart. So let's go back to algebra 1 for a minute. Okay? If you have x squared times x cubed, you really have x to the 2 plus 3 power. Do we agree on that? Okay, so what we right now is we have the 2 plus 3 power. I want to undo it. So to undo it, I switch it back to multiplication. So what I have here is e to the natural log of the square root of x squared plus 4 plus e to the c sub 1 power. I'm not, sorry, not plus. Times. My fault. Times. Okay, so I'm going to keep going right here. So y equals, what happens with the e and the natural log? They cancel, so I know that that piece is the square root of x squared plus 4. Isn't this just a number? E is 2.718 to some constant. It's still going to be a constant, so we would just rewrite it as C. So there's your final answer on that one. This thing here, where we've got to tear it apart, very, very common in these problems. We did it a lot last year, and we're going to do it a lot more again this year. Okay? All right, we good with example 1? All right, let's try example 2. So instead of y prime, what would we rather see that as? Yep, dy dx equals 6 cosine of pi x. All right, what are we going to do with this dx? Multiply to get it to the other side. There's nothing else to move besides that, so that's our separation. Equals 6 cosine of pi x dx. All right, what's the next step? Integrate. Doesn't matter if I keep the 6 inside or outside. On the left side, what do I do to integrate the y? Over what? 2, good. On the right side, I'm going to need a u for this piece, right? Yeah. So u is going to be pi x, which means that du equals what? Pi dx. I don't have the pi, so I got to move the pi over. All right, so for the pi x part, I put in u. For the dx, I put in 1 over pi du. Does everybody okay with my over pi out front here? Understands where it came from? Okay, so now let's integrate cosine. When we integrate cosine, what do we end up with? We end up with sine, that's right. Sine. What am I putting in instead of u? Pi x plus c. I don't think we're going to have a c sub 1 on this one. The only other thing I would do is get this 2 out of the denominator. How do we get that 2 out of the denominator? Multiply by it. So we'd end up with y squared equals, what, 12 over pi sine pi x plus c. They let you leave it squared. I don't know that why, but they do.
How do we know when we need the c sub 1 or c sub 1?
If you play with it, as you're going through it and you see that your constant's going to change, then you can go back and write it in. Okay? I probably personally wouldn't mark it wrong if you didn't put the c sub 1, you just left it as a constant, but you'll see, I don't know, you'd have to talk to the college professor. Most people won't look at the steps in between. Like the answer book won't even show the different c's. They'll just show the end. Okay? All right. Let's see what this next one looks like. All right, so we would rewrite as the square root of x squared minus 9 dy dx equals 5x. Okay. So we're going to start it together. I'm going to let you finish it. How do I move this to the other side? Divide it. Good. So you have 5x over the square root of x squared minus 9. How do we move this to the other side? Multiply. All right. Now we're at the point where we should be able to integrate it. You're going to need to use substitution. That's the only hint I'm going to give you. I want everybody to take a minute and try integrating that on your own. So everybody's integrating without talking to your neighbor. Take about another 30, 45 seconds, and then we're going to check it together. All right, let's see how we did. Alec, what'd you get for your U? Good job. All right, everybody, so when we take the du, what do we end up with? Good. All right, and what we have an x, what are we missing? The 2, so I got to move that over. All right, so when I integrate dy, what did we get? Do I need natural log this time? Just what? Just y, right? I don't even need the 1, but you can write it. It's okay. All right. I'm going to throw the 5 out front. For this piece right here, actually, I'm going to do a couple of things at once. So watch what happens. Because we're in BC now. I don't need to show every single little step. The u is this, right? Instead of writing square root, I would write what? 1/2, and to bring it upstairs, I would write... See how I did that all in one step? Saving myself lines of work. Okay? If you have to show all the steps, that's fine, but I'm saving myself lines of work. For x dx, I'm putting in 1/2, so out front, du. Okay, let's see what we can do with that. When I integrate y to the 1/2, what do we get? I'm sorry, u to the 1/2. You get u to the what? U to the 1/2 divided by 1/2 or multiplied by 2 plus what at the end? What goes here? C. What am I going to put in the parentheses instead of u? Good. Okay, I'm going to spend one line cleaning it up and then we'll be done with this one. What happens to these 2's? Cancel, so you'd end up with y equals 5. I'd probably convert it back to a radical, square root of x squared minus 9 plus c. Make sure you got it right. What do you mean, why wouldn't it be natural log? There's no 1 over anything anywhere. That's not anywhere, right? Okay. And you can't, in the square root, it has to just be a power of 1 in the denominator. Okay? And if it's not a power 1, then you're bringing it upstairs with an exponent. Okay? All right, everybody got it? I can move on. All right, next one. So now we're going in and we're going to solve for the C. When we see that's find the particular solution, that means we have to solve for the C. If they give you an initial condition, you should use it. If you go through the AP test and there's an initial condition and you never use it on any of the 4 or 5 parts of the problem, you got the problem wrong somewhere. Okay? They always use all the information for the most part that they give you. So the first thing is we got to separate these variables. Which is a little bit more challenging, it looks like, on this one. The first thing I'm going to do is, it looks like I'm going to move this entire thing, even though it still has a y in it, to the other side by doing what? Subtracting. Okay, good. So e to the negative x squared y squared minus 1 dy equals negative xy dx. Now let's see if we can get the x's together and the y's together. How would this piece here move to the other side? I like the division. And then how would I move this piece here to the other side? Isn't it still dividing? So right now it's multiplication, so to get it to the other side, we would divide. Okay. Before I integrate, I'm going to do a little bit more of playing with this. Okay? Is this one here happy? He's not happy, so to bring him, that means I get to bring him upstairs to make him happy. So I'd have negative x e to the x squared dx. That looks much better. Okay? Over here, it's the same thing as saying y squared over y minus 1 over y dy. What is this thing really? What does that reduce to? Y. So we really have y minus 1 over y dy, and then we're going to integrate that piece. Here I could throw my integral symbol on there. All right. So let's finish the left, and then we'll come back and do the right. So when I integrate y, what do we end up with? Y squared over 2. When I integrate 1 over y, what do we get? There you go, natural log of y. Good. So that side is now integrated. Okay. On this side over here, what would we use as our u? Good. So du is what? Good. And we have what missing? The 2, so I'm going to move that over. Okay, so over here I've got a negative, and I've got, e to the u. I apologize, I'm messing that up all over the place. E to the u, and then for the x dx we put in 1/2 du. All right, when I integrate e to the u, what do we get? E to the u, and instead of u, what are we going to write down? X squared plus c. All right, do not try to simplify that, okay? The nice thing about this one is it says give us the initial condition, and then we're just going to solve for c and plop back into this exact equation, okay? So let's put in our values for x and y. So what goes in for the y? 1. So let's see, I have 1 squared, which is 1/2, minus the natural log of 1 equals negative 1/2 e. What am I putting in for the x? 0 plus c. It still looks worse than it is. All right, from last year, who remembers what the natural log of 1 is? It is 0. Get used to that. We use natural log of 1 in here a lot. Okay, the natural log of 1 is 0. If you don't believe me, type it into your calculator. Okay? So we have 1/2. What's anything to the 0 power? 1, so we have 1/2 equals negative 1/2 plus c. So if I add the 1/2 to the other side, what do we get? 1. 1/2 plus 1/2 is 1. So to get my final answer, I go to this equation right here, and I write the exact same thing. Instead of writing c, I'm going to write a 1. So y squared over 2 minus the natural log of y, that says minus the natural log of y, equals negative 1/2 e to the x squared plus 1. All right. Let's try it again together, or at least part of it together. All right. What am I going to write instead of y prime? dy dx. Okay, and at the same time, I'm going to move this to the other side. How do I move that to the other side? We're going to add it. Good. So natural log of x squared. Okay, how do we move the 2x to the other side? Divide it. So natural log of x squared divided by 2x. And how do we move the dx to the other side? Good. All right, this one is weird. Really weird. So your u this time is going to be the natural log of x squared. So the whole numerator. You'll see why in a second. Okay. So du is equal to, when I take the derivative of natural log, what do we have to do? Yep, 1 over inside the inside, so 1 over the mass, right? What's the chain rule derivative piece? 2x dx. Now let's cancel and see where we're at, okay? So let's see, the x goes away with the x squared. So I am down to du equals 2 over x dx. I have the over x part, right? Look at what we've got. We have this piece. Do I have this top piece? Not in the top. I have a 1/2, not a 2. Okay, so I still need to move the 2 over. So I'm going to divide by 2. So du equals 1 over x dx. Okay. All right, what do we get with when I integrate dy? Y, good. Let's start putting in our u stuff. So the top is u. The 1/2 goes out front. What about this 1/2? Don't I have 1/2 times 1/2? What's a better way to write that? Are we okay? I'm not even going to write the work down. I'm just going to do it in my head. So I had the 1/2 here, and the 1/2 here that I sub in, and it's 1/2 times 1/2 is 1/4. du. All right, let's integrate it. So 1/4. When I integrate u, we get u what? 2 plus c. Okay, for u, what am I going to put in? Good. And instead of writing 1/4 times 2, I would write 1/8 natural log of x squared squared plus c. Don't try to make it x to the 4th because it's not. Okay, the squared is operating on the log. Okay, they gave me an initial condition. I now need to plug that in. Okay, so I'm going to come over here to do that. So what am I going to put in for the y part of this so I can solve for c? 2, good. 1/8 natural log, what's going in for the x? 1, which squared would be 1, plus c. What's natural log of 1? So doesn't that whole thing zero out? You're left with 2. So again, we're going to plug into this guy exactly the way he looks and replace the c. So 1/8 natural log of x squared squared plus 2. There's your final answer. The good news is the last one is a 2-liner. You're going to like the last one. We good with 5? Okay, so 6. Find an equation of a graph that passes through the point and has the given slope. What are the 2 things we need to write an equation? Point and slope. I have the point. I need to calculate the slope. So let's calculate the slope really quick. What am I putting in for y? 3. What are we putting in for x? 1. So what do we end up with? 3. Y minus, what's your y value? 3 equals your slope times x minus. We like that question, right? Done. Okay. All right. So the homework assignment is there. Notice it says to skip 8, 10, and 16. Those ones must have been brutal. It is also, I believe, posted in haiku, right? It is? Okay, good. I did get it up there. Alright, and you have some time left. If you are ready for me to stamp homework for homework 2, you can come back and see me. I'll take care of it for you. Okay? Yeah, you can get part of it stamped, but I won't stamp off the full week until that's done. Okay? Yes, take the pass. You ready for stamps? I need your homework notebook. I need that. The notes notebook.